Unit 5.1, the mean value theorem. We use the mean value theorem to justify conclusions about a function over an interval. The mean value theorem. If a function f is continuous over the interval bracket a to b bracket and differentiable over the interval parentheses a to b parentheses, then there exists a point c within that open interval where the instantaneous rate of change equals the average rate of change over the interval. The formula is f prime of c equals the average rate of change formula, which is f of b minus f of a over b minus a. And on the graph, just to draw a representation, we'll draw this formula. Let's label this point A and this point B, and we'll draw a secant line connecting them, and that's the slope of the line between those 2 points. And then we want to find somewhere else on the function that has the same slope, which looks like these 2 points right here, and we'll draw parallel lines, and we'll label these C. So yeah. Number 1, use the function f of x equals negative x squared plus 3x plus 10 to answer the following. A, on the interval 2 to 6, what is the average rate of change? Average rate of change formula is just f of 6 minus f of 2 over 6 minus 2, which is negative 8 minus 12 over 4, which is negative 20 over 4, which is negative 5. B, on the interval 2 to 6, when does the instantaneous rate of change equal the average rate of change? First, we have to find the derivative of the formula. So f prime of x equals negative 2x plus 3. Now, we set the derivative equal to 5, or negative 5. Solve for x. And that will be x equals 4. So now we know that the answer of when the instantaneous rate of change equals the average rate of change is when x equals 4. Mean value theorem versus intermediate value theorem. Mean value theorem, that is the derivative or instantaneous rate of change, must equal the average rate of change somewhere on the interval. Intermediate value theorem, on a given interval, you will have a y value at each of the endpoints of the interval. Every y value exists between these two y values at least once on the interval. A hot air balloon is launched into the air with a human pilot. The twice differentiable function models the balloon's height, measured in feet, at time t, measured in minutes. The table above gives values of the h of t and the vertical velocity v of t of the balloon at selected times. First things first, since it says twice differentiable, we know that it's continuous. So A, for 5 is less than or equal to t is less than or equal to 20. Must there be a time t when the balloon is 50 feet in the air? Justify your answer. First, we know that since it's twice differentiable, h of t is continuous. And we also know that h of 5 is 40, and that h of 15 is 70. So now that we have our proof, we can make our answer or our justification statement that according to the IVT, intermediate value theorem, since it's dealing with the intermediate numbers, there is a value C such that H of C equals 50 and 5 is less than or equal to C, which is less than or equal to 15. B, for 20 is less than or equal to T is equal or less than 30, must there be a time T when the balloon's velocity is 1.5 feet per second? Justify your answer. This is the MVT. So we could just do H of 30 minus H of 20 over 30 minus 20. And this is 80 minus 65 over 10, which is 15 over 10, which is 1.5. Now that we have our proof, or done our work, we can justify it by saying, according, or answer to the MVT, there must be a value C where 20 is less than C is less than 30, less than or equal to 30, and H prime of C equals 1.5.